Hello. Today we're going to go over vectors in 3D space. So I'm going to go over a few problems from the practice. And, oops, sorry. Here we go, vectors in 3D space. So before we do this, let's talk about what 3D space is. So our normal XY plane, this is X and this is Y, is a 2D space. And we have our points that are X, comma, Y. So imagine if we take this 2D plane and we put it over here. So here's the x-axis and here's the y-axis. And over here, this is the positive space. So imagine you have your sheet of paper with your x-y axis on it. And now we have this third dimension going this way, which is z. It also goes the other way. So this is our three-dimensional space. So in our three-dimensional space, we have points x, y, z. We don't have to actually graph these. I just wanted to give you a visual of what we're talking about. It basically works exactly the same way as our 2D vectors. So let's work some problems. So here's a problem where I have vector u and I have vector v, and I want to find 3u minus 2v. So I want 3 times vector u, and this is going to work just like with the 2D vectors. I'm going to multiply all these numbers times 3, and then minus 2 times vector v, which is 1, 1, 2. So this becomes 15. 3 times 5 is 15. Negative 6, 9. And then I'm going to distribute the 2 over here, but not the negative. So this becomes 2, 2, 4. So when I combine these together, I'm going to get 15 minus 2 is the x component. Negative 6 minus 2 is the y component. And 9 minus 4 is the z component, giving me 13, negative 8, 5. So if you understood the 2D version of this, this is very similar. It's just with the third dimension z. Okay, next, I want to write vector EF as a sum of unit vectors. So there's two different things going on in here. First, I have to write vector EF, which again is exactly the same, as I wrote vectors in 2 dimensions. So I start with the second point where I'm ending up and subtract the first point. So this is 6 minus negative 5 is my x part. Negative 6 minus negative 2 is my y component. And then 6 minus 4 is my z component. So this becomes 11. Minus a negative makes it plus, negative 4. And then 6 minus 4, sorry, my phone keeps going off, is 2. So this would be my vector if I wrote it like this. So unit vectors are I is the unit vector that tells me to go 1 in a positive x direction. J means 1 in a positive y direction, and K is 1 in a positive z direction. So this is the same as 11I and then minus 4J plus 2K. That's all this is. So that is, what's that? B. Okay, so I wanted to talk about that. I want to talk about finding a vector given 2 points in 3 dimensions, and I wanted to talk about the unit vectors. Okay, find vector Tm. So that's exactly what we just did a minute ago, and then find the magnitude. So vector Tm, I'm going to find that. Oops, sorry about that. Okay, and so I'm going to take out a few steps here. I'm just going to do negative 3, the x component, minus negative 2, so that makes it plus. So that's negative 1. And then 5 minus 4 is 1. And then 2 minus 7 is negative 5. So that's my vector. So I can look for that for part of my answer. And so it's not A, and it's not C, but that is the vector in both B and D. Next, I need the magnitude. So just like I find magnitude in 2D, I do it the same way here. It's the square root of all of these squared added together. So negative 1 squared plus 1 squared plus negative 5 squared, Remember, when I square a negative, it becomes a positive. So this is 1 plus 1 plus 25, which is the square root of 27, which I can simplify. 27 is 9 times 3. The square root of 9 is 3. And so I get 3 square root 3. And so my answer is D. So again, just like in 2D, I go through exactly the same actions. I just have to do it one more time. So I put one more in here, and just because this one is a fraction. I have 3 vectors, but I only want 3/4 times v. So make sure and get the correct vector. That's 4, -3, 5. And then minus w. So that's 2, 6, -1. So I wanted to do one with a fraction. So 3/4 times 4 is 3. 3/4 times -3 is -9/4. 3/4 times 5 is 15/4. And then I'm going to subtract this vector. So 3 minus 2, the x component is 1. This is going to be a little harder. This is -9/4 and then plus, or sorry, that's going to be minus. 6 in terms of fourths is 24/4. So I'll come to that in a minute. And then 15/4 minus a negative, so that makes it plus 4/4. So that's 1, -33/4, 19/4. Now, none of my answers look like that. I've got to convert these fractions into mixed numbers, which I personally don't agree with, but that's what they did. It's cool. So up here, I get 1. And so 4 goes into 33 8 times, and it's negative. 8 times 4 is 32. So there's 1 left over, -8 1/4. 4 goes into 19 4 times. 4 times 4 is 16, with 3/4 left over. So 1, -8 1/4, 4 3/4. Oops, it's A. I don't know why I did that. I keeps closing. Okay, so there we go. That's it for vectors in 3D. Again, as always, please email me and let me know if you have questions, you need help. Don't forget to be emailing me your notes. Have a great day. Take care.